Okay, in this video we're going to look at applying transformations, and we're going to do it with the mapping technique. So remember, there are two main techniques, mapping and matrices. Either one is valid. However, on VCAR exams, quite often questions come up requiring you to recognize matrices. So it's important you understand the matrices. But in terms of applying matrices yourself, applying transformations yourself, if you've been given a list of transformations, I think mapping is often a bit more intuitive to follow. So we're going to look at mapping through this video. So essentially what you do is you apply each transformation in the given order one at a time when using your BODMAS. And to do that, let's look at the summary below. In this table, you've got from the x-axis means you're affecting the y value, so you're multiplying it. From the y-axis means you're multiplying the x value, stretching it away. Reflection is changing the y value or the x value depending which axis, and you're adding a value to x or value to y depending if you're moving sideways or up and down. Of course, if A is negative, you're moving left and down. If A is positive, you're moving right and up. Remember your notation, I should have said this before. XY is your original point and image x dash y dash. So you start with the original, you apply transformations, and you end up with x dash y dash. Once you've applied it, you transpose your equation and get x by itself and substitute into the function. Let's have a look at this example. We got y equals x squared. We're applying the following transformations and we're asked to find the equation of the image in each of the cases. So I'm going to use the mapping technique as said. So we start with x, y, and then we're going to apply each of these things to it. So vertical translation of 1 unit up means I affect the y value by adding 1 to the y value. The next one, it's a horizontal translation of 3 units left. So take the x value and I'm moving all the x values to the left 3. So minus 3 plus 1. The next one, we have a dilation of factor 2 from the x-axis. Now from the x-axis stretches the graph up, pulls it away, so it's changing your y value. So again, I'm going to leave x minus 3 there and we apply BODMAS. So this whole thing that's already there is now doubled, not just the y, but the 1 as well. And our final step is a reflection around the y-axis. So around the y-axis affects the x value because the coordinate there goes directly across over to there. It's around the y-axis affects the x value. So I'm going to put a negative in front of the whole thing, not just the x. Again, the whole thing is being moved to bracket y plus 1. So I've done the mapping. That's the technique. From this point onwards, whether you're doing mapping or matrices, it's the same, but getting to that point there is a different bit. So now I can say that x dash, the image, is equal to the original x minus 3 multiplied by negative 1. And the image of y is given by the original y plus 1, then doubled. I now need to get x and y by itself because I want to replace them in the original equation. I mean, the original equation y and x in here, that is this y and x. I need x dash and y dash to go into that equation, and the way I do it is by getting x by itself. So first step is divide by negative 1, so you get negative x over there, and then you add 3. So negative x dash plus 3, and we're going to substitute this into the equation above. And this other one over here is going to be y plus 1 equals a half of y dash, and they're going to subtract 1. So you're going to have y dash minus 1, like that. And that is our expression for y in terms of y dash. And these two now replace the y and the x in the original question. So there's y gets replaced by that expression there, and x gets replaced by this expression here. And we end up with y equals x squared becoming 1/2 y dash minus 1 equals negative x dash plus 3 squared. And then we transpose to get y dash by itself. So we add across by 1. We've got 3 minus x dash squared plus 1 and times by 2. Sorry, didn't write that very well. Squared there plus 2. And there's your result. You might often find that this 3 minus x squared is written as x minus 3 squared. And that's because it's the same thing. Remember, 3 minus x squared is the same as 3 minus x times by 3 minus x. And if I take a negative 1 for a factor out of both of them, you'll get x minus 3 times x minus 3. Those negatives will cancel out and you're left with x minus 3 squared. So be mindful that that might come up. So in our case here then, you found that the equation of the image under those transformations is that, and that will be exactly the same as if you did the matrix method. Let's look at another example. So y equals root x is the following transformations applied, reflection around the x-axis. So we're going to start with our x and y. Then we're going to reflect around the x-axis, which means the y value is being changed. Remember, it's here, x-axis is your mirror going down that way. It's doing exactly vertically. So you're just changing your y value. Then we got translation of 4 units to the left, which means the x value has 4 taken away from it. So it's moving that way. So this one moving that way. And then 2 units down. So taking away another 2 from that. And then dilation factor of 1/3 from the y-axis. This thing from the y-axis affects the x value. So you end up with 1/3, and the x value was, as a whole, it was x minus 4. So the whole thing is affected, not just the x. If it was in a different order, if it had a dilation factor first, then the translation, it'd be 1/3 of x, and then I just chuck minus 4 at the end. But because it was already translated, that dilation will affect your translation. Now at this point, again, I can say, well, I'm now finished. So the image of x is given by 1/3 of the original minus 4. And then the image of y is negative of the original, take 2. And that transpose again to get x by itself. So I times by 3, and then you get 3x dash equals x take 4, and x is 3x dash plus 4. That is going to be substituted into the equation in a minute. And the other one, I'm going to add y across and subtract y dash. In it with this one here. And once again, this is going to replace y in there, and this is replacing your x there. So into my equation now, y equals root x. This becomes now negative y dash take 2 equals square root of 3x dash plus 4. Negative y dash equals 2 plus the square root, or you can put the square root first and put the plus 2 at the end, doesn't really matter. And then we're going to divide by negative 1 to get our equation there. And you could actually deduce it from the start, one by one, as you go with your equation, right at the equation every step, but it's probably a bit more simple to have your mapping or your matrix method. And that is how you use the mapping method of transformations.